I'll talk about a bit about hardening and image security. I always talk about the things that people hate about. So, but I think it's very important that we talk about it, because with the changes that world is moving thick and fast, people are restructuring themselves. It's nothing new, but with DevOps, right? Everyone is realigning themselves to the power of containers, getting into microservices and all this. It also throws one thing open, that the more faster you grow, right, you leave a lot of trails, and people, as the world is getting more and more uh, uh, a rest world, I would say, right? Because they like to attack themselves. People earlier used to be like quite, they used to be within themselves, but as the internet exploded, right, people have also started to find areas where they can take information, because information, as we say, is gold right now. Earlier we used to say coal, we used to store physical gold, but now Bitcoin is the gold, right? So similarly, information in our landscape, where we as guys who are logged in today work, it's the gold, right? So who am I? I just, this is me. You can come and say hello whenever you are. You can find me on LinkedIn. I work as a DevOps architect with Thinknyx Technologies. I've been 21 years in the IT information space, working across a lot of areas, but my core areas have been towards the investment banking side of things. I've been here for 16, 17 years, but I've been doing IT for the last 21 years. And I've seen a shift across, from coming from, where you had data centers, which were physical in nature. We would go rack and stack things ourselves on a DRD, would always go to the other side of the spectrum to power off service, power on. And then the last 5-6 years, we have seen the explosion of, everything going virtual. Virtual was there when VMware started to do this in 2006. It was there before VMware as well, but we are more virtualized kind of stuff with containers. And one of the important things that has come up in the container world is Kubernetes, which a lot of people think it's container orchestration. But for me, I was listening to one of the Google talks somebody gave 1 year back, and he said Kubernetes very correctly, that Kubernetes is, people think it's an orchestration tool. Yes, it is, but for me, it's infrastructure, right? If VMware is an infrastructure enabler, then why does Kubernetes not sit in that paradigm? If you think about it, right, it gives you that virtual layer, from where you can provision your containers. What is a container? It's an infrastructure stuff that you're provisioning. You are transgressing your networks, you're transgressing everything through it, right? So for me, if you ask me to define what is Kubernetes, it's a container orchestration tool, but at the same time, it's an infrastructure enabler as well. So it should really sit within something as an infrastructure tool, rather than just being called as a container tool, or container orchestration tool. So what are we talking today? We'll talk about security, not in just in terms of Kubernetes security, but we'll also talk about a bit about where it sits. And when I say where it sits, I'll talk about operating system security and why is it important that your operating system is secure. We'll talk about how this can be achieved, the security and hardening, what are the principles behind it, who governs us. We all know that the only governing body that sits for us in the information technology, which every auditor comes and hits us hard, is the CIS compliance. People call it NIST compliance. They have various tools to do it. Then everything that runs in the container world hinges on images. We all know it's the basis of everything. People talk about rootless containers, but again, it's still got an image, right? So we'll talk about a bit about image security, and I'll try to show you, right? Talks are always loose, I believe, but when you see this in action, is always that becomes important. So this is the agenda for today. Let's start. So why are we talking about all of these, right? Over the past 4 or 5 years, right? Or I would say that people used to think Linux was very secure. There's no one who can put a malware. There's no one who can put a virus. And hence people used to laugh at Windows all the time, hey, you guys need to patch, hey, you guys need to do this. But look, over the past 4 or 5 years or 7 8 years for Linux also, the amount of vulnerabilities that are coming in are coming thick and fast. People are trying to patch their systems more quicker. Earlier, organizations that we used to work, we would patch systems 6 months or 3 months. If we patch the system 1 year also, nobody would care, but organizations now starting to patch very fast because they know that attack vectors have increased. The surface areas are getting reduced, because the canvas is expanding, which means even if a low patch is not patched, people or attackers do not attack you on any high vulnerabilities anymore because they know organizations are going to patch that. But they'll try to attack you on smaller stuff, which people know that people are not going to patch it, because most of the IT guys, what they do is, oh, I'll patch only the high and the critical ones. Why do I need to take a reboot? Why do I need to do an extra work? But that is where attackers are getting smarter. They will not give you respite, right? Attackers sit while you sleep, they attack you, right? So you need to be careful in what you are doing while you're sleeping, because while you're sleeping, nobody's checking, what things are happening, because you might have a 24/7 team, but those guys might be sleeping as well, but and we have seen, I've given you a couple of examples right there, that Tesla was cryptojacked, and that was on a Kubernetes cluster. There was an audit done by ZDNet where they say third-party container applications, 96% of them are vulnerable. There are a few more for Azure State, who did some again vulnerability stuff, and they found that they can compromise, attackers can compromise other public accounts, and we all know about what happened with SolarWinds. It was a binary that was packaged up by a very good company, but once it was installed, it started to unravel. But people are also trying to see, back on SolarWinds attack, that there are malware found in other stuff as well. And that's where it becomes very important, that we, as we expand ourselves, everyone talks about cloud. Everyone now talks about Kubernetes as well. Hey, your organization, is it not using Docker? Is it not using Kubernetes? Yeah, we are using it, but how are we using it? Nobody asks, and the ask only comes when somebody happens to us. Nobody asks when things are going well. For organizations, even if you do simple things, even if you bring a new computer or new MacBook, everyone is glued to it, right? Says, look, my organization, has given me Mac. They become so happy, but something happens, right? And suddenly people start to think, ooh. So the same thing happens, till the time the infrastructure is functioning correctly, till the time things are going well, nobody asks a question. The day something goes wrong, and I'm almost sure, everyone would have gone through a day, where something would have gone bad. So the similar thing happens when you get attacked. Look at a few days back, you heard about 2.4 Tbps DDoS attack on Azure, which they were able to fend, and that's where I say the firemelon attacks, and the moment the firemelon attacks, what happens is your infrastructure is compromised. And the moment your infrastructure is compromised, we all start running like headless chickens, trying to find out what happened. You get forensics involved. If you're hit by ransomware, you start to see, do you have money in the bank account to pay the guy back or not? So why is this very important? I've covered a bit of aspect. One, auditors are becoming more and more, as you can understand, the security budget of each and every company is increasing. So the whole governance model, which was based upon a framework, that has expanded into more towards security governance as well. And security for any organization has started to become the forefront of everything they do. The budgets, like the military budgets, expanding for every country across the globe. Let it be India, China, US, Russia. People, even when they don't have money, like North Korea, they are putting so much of money in their security apparatus, right? So security governance is becoming very important in the cloud space. talk about anything in cloud, they'll all talk about security rules, this, that, are you encrypting, encryption at rest, encryption in transit. They're talking all about it, right? People used to talk about DevOps, but there's no DevOps now. People don't talk. Most of the people that I interact with, they don't talk DevOps now. They say DevSecOps. So what is that DevSecOps? DevSecOps is nothing but putting again security to the front of things, which means while you would naturally do all your work and then pass it to the security guys to say, guys, do you approve this happening in my environment? That was old day, people still do it, but if you do that right, you slow your pace. But at the speed at which, breathtaking speed at which we are moving, right, it's very important that we move security to the left, so that anything that has to happen, any security governance that has to, any rules that has to be applied, move left. By doing that, what we get is a reduced surface attack area. By meaning that reduced surface attack area means you will get people to attack you, right? You'll always get malicious actors to come and attack you, right? The militias will come, they will attack you, but the less point of objects that you give them to attack, the more secure your infrastructure is, the more secure your perimeters are. And it's like saying, you have put 10,000 locks on your door, you might have a 7-latch door, but yeah, it's good when the door is closed, right? But if you keep that door open, even though you have 10 locks or 50 locks attached to a door, right, that door is doing nothing. You're allowing someone to come in because you have kept the door open. So by doing all this, what you should always think about is any loopholes that you can close within your infrastructure, close it, because the more you keep it closed, people are not going to come in. So how do we get there? So the first thing that you do is platform and Kubernetes security. So why do I call platform as secure? Because, hey, your Kubernetes cluster is there, which might be highly secure, or you have rules on the cloud, which says, okay, only these rules are allowed, these people are allowed. What if somebody breaks your cloud rules, right? What if he gets to your infrastructure? Then your infrastructure is done. All your deployments, he can shut down your complete deployment by a single command. So it's only about one point of entry that the guy needs to take to come and shut you down, right? So it's very important that not only you secure your firewalls to help someone come into your organization, but what if he comes? Because we all see, that if FBI can be breached, we all can be breached, right? So platform again, okay, your Kubernetes cluster is secure, but if your operating system itself is vulnerable to things, the guy can use your vulnerabilities inside your operating system to get inside your containers and still terminate you down, right? So that's the reason I was talking about that you should not only think about Kubernetes security or your firewall security, but also think about platform security. So how do you secure your operating system? And in my previous talk, I've always talked about, securing your infrastructure is important, but securing your operating system is the most important thing that you can do. So how do we do that in the Kubernetes landscape? Look, you have to do two things, right? You have to look at the runtime security. When things are running, you need to see what's coming in, as Mamta was explaining, the ingress rules and egress rules, and seeing what a binary is doing. But from platform side, you have to run some CIS benchmarks, which you can see, because normally people deploy Kubernetes, but they don't see that they have left over their APIs open, they have left over files, permissions open. And that is as good as saying people come in and do whatever you say, right? So Qbench, I'll be demonstrating this. It's a very beautiful tool coming from AquaSec. I'm a big fan of Aqua guys. And it helps you benchmark your cluster and secure your cluster. It will also, you have benchmarks for operating system, which you should generally apply. You don't apply blind, but you should apply. So we'll see this tool in action. It tells you what are the vulnerabilities on your worker nodes, what are the vulnerabilities on your master node. Once you've secured that, you are secure. Your APIs may be open. It tells you if your API is open as well. So that's one tool that I'll demo you out. The second thing is the image vulnerability, right? So we always, as I said, images are the base of everything that we do. Again, I'll use a tool from Aqua. Big fan. You can put all of these in your CI/CD pipelines with Qbench. Also, you can put this on a daily roller as a job in a scheduler. like a kube scheduler, or you can run it daily on your as part of your auditing in a cron or something, and you can keep on getting your stuff out, right? So Trivi, again, images are basis of this. If your images are bad, no matter how good your Kubernetes deployments are, no matter the microservices are doing what they're doing, if the images are not secure, your defense is completely broken. People will use those. So we always say, start from good base images. Don't take images which happens from take you from internet, use it, right? Even if you take it from the internet, try to secure it, then get the application guys to use those images. Once those application guys have packaged on top of that image, done something, rescan the image, and that image, when it's in your image bakery, in your artifactory, when people use it, that you're using an image which is very, very, very secure. So without much ado, I'm just going to show you. I hope the demon gods work for me today, and I can show you the demo. Right. So this was a cluster that I still hope my cluster is still visible, and you can see my cluster, right? So the first thing first, platform security. How do you secure your platform? I came in as root, that's one of the biggest mistakes. So for anyone Kubernetes admins out there, right, the first thing you should do is to secure that your Kubernetes master nodes are not accessible by people who do not need to have access to, which means that why do you need access to Kubernetes masters? You can do your deployments from kubectl outside. So why do you need access to the machine itself? So lock down your machine to as less people as possible is the first thing you could do. The second thing you could do was, you don't need people to come onto your clusters to run your kubectl commands, right? So you can always have kubectl binders running outside. Everyone has its own config files. You can use that to connect to the cluster. So try to keep them away from the machines from where they can do their deployments. That's the second thing. The third thing that you should do is to patch your operating system regularly, because as I said, most of the attacks that are happening now are happening because people are not patching their low CVs, but you should always keep your operating system up to date. The fourth thing you should do is always keep your Kubernetes cluster also up to date, because there are known vulnerabilities which come out of every versions of. If you do not patch your Kubernetes, if you think that your Kubernetes cluster is stable, deployed, and you're happy, people will find about the versions of Kubernetes that you use. They can use that to attack. So always try, like you update your iPhone security or your Android security, right? The same way goes for Kubernetes. Try to be on top of the game. So what am I showing you today? The first thing I'm going to show you today is Qbench, because I wanted to show you extra apart from. So what does Qbench? It's a very small RPM that you can install. You need to just install it on one of your masters. I just install it here. And then what do I need to do? If I need to find out all my vulnerabilities on the master, I just run my Qbench command. It tells me out of about 61 checks, 43 checks passed, 10 checks failed, 11 has got warnings. If you need to fix anything, these are the fix that you need to apply. But you can easily see, that my cluster is not secure. It has got vulnerabilities which attackers can use to come and see. But it gives you all these reports as well. You can it tells you what each item is doing. So it tells you what it is there. You have a failure. The certificates are set as automated admission control. Plugin pod security set automated. You should not use it. You haven't got an auditing path set and all this. So these are there. What do you need to know about your nodes? The node also passes 19 checks. One check is fails. So hopefully, as I said, look, it's talking about TLS ciphers and all this. And they play a big role, part of it, right? Maybe you're not rotating your certificates and all this, you're not protecting your kernels. So they give you all this, and this is what you can use to find out if there are vulnerabilities. If somebody was to change something in your Kubernetes cluster, if you run this on a daily basis, you will know it. If you need to only target a couple of checks that you want to do it on because everyone doesn't want to do every check, right? So you can run this, where are the, once you install Qbench, where are the config state? It's not only for Kubernetes, for everyone's knowledge, right? You can run this on an OpenShift cluster. You can run this on GKE, AKS, EKS, wherever you want to run. There are benchmarks created for everything, but on your managed clusters, you need to run it as a pod. So you need to run it as a deployment. It will spin up a pod, and once the pod is there, it will run your benchmarks and do it. So all the benchmarks are here. You can customize it according to your needs. You have master.yaml. So these are all the rules that I was hitting. You can modify it for your stuff and do the stuff. So you can see easily you get benchmark very easily, right? Let's talk about the other one that I was talking about, because I think I've got few more minutes, about 5 minutes, because we are running late. So I'll try to be as quick as possible so that we're back on track. The second thing we talk about is Qbench, Trivy. So how does Trivy work for us? So let's install Trivy. Again, Trivy is a very small binary. You should put it as part of your CI/CD pipelines. Very easy. It can run as part of a container image. So there's no excuse for people not using Trivy. Again, free of cost. You don't need to pay anything else. So let's look at a bad image. How does Trivy work for us? The moment I passed on a base image that I picked up from the internet, it tells me you already have got 2 vulnerabilities, and both of them fall into a category of a high and a critical. People always used to use, say, Alpine is the smallest image, but last year it unraveled that it was one of the least secure images. They have secured it now, but that's what I'm going to show you. But you can easily see that I picked up an image that tells me. So the first thing, that whenever your organization, your developers tell you to bring an image, you as custodians, yours or your guys who manage the platform, when I say platform, it's the Kubernetes platform, you should always check that your base image on top of which the image is going to build passes these checks. It tells you that there's a discrepancy. It tells you the CV. Either you pass this image itself and make it secure and give it to the developers, or you seriously shouldn't be using the image itself, right? What's next? Let's look at then the latest image of Alpine, if I wanted to use it, right? So let's see if it's got a vulnerability or not. It's got 0 vulnerabilities. Hey, good, done. So what should I do? I should use 3.14.2, right? And that is job done. My base image is secure. Once the application guys put it on, I know I started. So whatever has been done is done by the developer. You blame the developer. Let's put up the Python image and you can see that there's so much vulnerabilities inside this small image. Look how many vulnerabilities you have. Do you want to start with this? Absolutely no. I wouldn't start my organization with this. In your CI pipeline, if you wanted to only scan for high and critical alerts, there you go. You can scan it. But again, as I said, right, the vectors are becoming smaller. So you should never allow something you do not want to. So even if it's small, you shouldn't allow. Right. That's about Trivy, that people know, right? I wanted to show you something more. And what that something more is the unknown that I found it in Trivy of recent. What's that? So I have a Docker file. I'm running an Alpine image. I want to, and people will be having this, right? So what you can do is, as part of this, right, your Trivy is part of your Docker image itself, and it installs itself. And let's try to build this image now, right? Let's build this image. So it should have been done by now. So Trivy said to me, guys, if you build this image, you have a vulnerability, so my pipeline itself will stop. So you can easily see, if I integrate this with my Docker file, run it through my Docker file, if the exit code is a non-zero exit code, nothing is going to run from the first stage itself. So again, I stop my attack vector because I'm not using a pretty bad image, right? What next? Right, now let's look at something else. So I have a folder, Docker file. What this tells me, I'm using Ubuntu latest. Never ever do the latest, right? Because you never know what is the breaking change that's going to break your cluster, right? Anti-pattern in Docker. If I use OpenSSH, why do I need to SSH into a container, right? I'm not putting an apt-get install telnet server -y, though I shouldn't be installing telnet server, but I'm installing it, just showing you. But -y I haven't put, which means my Docker file will stop doing this. If I do not put a user by default, which means my container will run as root, right? For a plain guy, he doesn't want to look at all this, right? So how do I get Trivi to scan this for me? Come on, Trivi, do my job, right? Trivi says, it did a Docker file security check for me, says the latest tag should not be used. There are a couple of documentation guys here. You could say, root user, you're running it as root user. It's a very high vulnerability. You shouldn't be running that, right? Port 22 is exposed, should not be exposed. It is telling me the update should be followed by a package install mine in the run statement, so it's telling me how you can optimize your code. It's also telling me that you're missing a -y operand, which means that, by just running simple checks, I am linting my code first rather than spending hours to do some work, right? Another 2 minutes, guys, I promise I'll be done, I'm always notorious for spending too much of time. So let's look at another thing, Kubernetes config, right? I have got a Kubernetes deployment. Anyone with plain eyes, can you tell me if there's any vulnerability in my deployment code here? Plain, nice, simple. So I think most of you guys, on the other side of the spectrum will tell me this is good, but I know this is bad, and I'll tell you why it is bad, right? Let's run trivia again. On my Kubernetes deployment file, it says this is bad. This is bad because this will allow you to take over root. And this is pretty much, I'll show you the reason for this. You can read this through, but if you use this host path inside your deployment config, this is as much as saying, you can take over as root, because this is a Docker socket, right? So again, misconfiguration. What else? Last one, guys. Let's look at what Trivi can do for me more. I have my Terraform configs, main.tf. Again, I'm allowing something, and then I have variables.tf, right? Let's run this through my Terraform config as well. It tells me I'm using, does not have outdated SSL TLS protocol. I'm using plain HTTP. I'm using classic resources, use VPC instead. My ingress traffic is allowing everything, and I'm not enabled disk encryption, So you can easily see, how I have used a couple of tools, which helps you get there faster. And if you're not still satisfied, where are this coming from? This is coming from something called as OPA, a Cloud Native Foundation project, which is Open Policy Agent, which helps you write policies against the object that you want to introduce in the cloud, and that helps you secure. And the last stuff, pod. Whenever you do your pods, right, there are a couple of security contexts that you can set. Your root by default, inside the container is a read-write layer, but if you put a security context of read-only file system, which means you're locking your root file system to not be able to be writable, because as you know, the root is nothing but coming from your operating system's root. So if I'm able to craft into my container, run something from my container's root, I may be able to craft something inside my operating system itself, right? So best practices, you should always try to set up your allow privilege escalation to be false, so that nobody escalates itself. You should always run your container as a user, which is not root, because if you don't set it, it runs as root. And what do I do if I needed to do my everything, right? See, I had all these folders beneath Privy, right? It scanned my whole folder and told me, which file has got which vulnerability for me. It talked to me about Kubernetes. I talked to you about Docker, and it tells me that, I had all these vulnerabilities, but the only test that passed successfully was my pod.yaml, and none of them had exceptions. But rest of my config all had issues in my config. And if I let this go to my environment, I know my environment is less secure than it should have been. Thank you, gentlemen, and everyone for listening. I hope it was insightful. It was just scratching the surface, but there's more to security. As I said, if you like to chat about, I'm on LinkedIn, ping me, or, you can ask us any questions. We are here at Thinknyx. Thank you very much.